In this video, we'll look at the intersection of three planes that intersect in a line of intersection. So we have three equations, x plus 2y plus 3z minus 4 equals 0. Call that equation 1. 2x minus y plus 4z plus 7 equals 0. We'll call that equation 2. And 3x minus 14y plus z plus 48 equals 0. We'll call that equation 3. First thing to do is write down their normal vectors. The normal vectors of a plane in this scalar form are just the coefficients of x, y, and z. So the normal vector of equation 1 is 1, 2, 3. The normal vector of equation 2 is 2, negative 1, and 4. And the normal vector of equation 3, its coefficients are 3, negative 14, and 1. We don't use the constants. Just looking at the normal vectors. And in particular, we want to see, are they multiples? But we can just glance at them. I hope you can clearly see n1 and n2 aren't multiples of each other. To get from 1 to 2, 1 times 2 is 2, but 2 times 2 is not that, and 3 times 2 is not that. So these aren't multiples. Same thing with n1 to n3. 1 times 3 makes 3, but times 2 by 3 you don't get negative 14. So normal 1 and normal 3 aren't multiples. And finally, how to get from 2 to 3 times by 1.5. Clearly that's not the case for the other components. So I'm going to write implies, since none of the normals are multiples of each other, there are no parallel planes. If there were, their normals would be parallel. Since their normals aren't parallel, there's no parallel planes. But now we want to look at the triple scalar product. And I'll write it down. We want to see, is this triple scalar product, n1 crossed with n2 dotted with n3 equal to 0? If it is, it's going to be something important for us. So let's look at the triple scalar product. First we got to cross n1 and n2. Please watch the video on cross product if you don't know how yet. So I'll cross n1 and n2. Here's my work, 1, 2, 3, 1, 2, 3. And I write down n2, 2, negative 1, 4. 2, negative 1, 4. Cross out these ones. So I got to write my answer, n1 vector crossed with the n2 vector equals, okay, cross product. That's going to be a vector answer, so I'll put a bracket, do the little fish. 2 times 4 is 8, and then minus 3. So you get 2 times 4 is 8, and then minus a minus is a plus. 1 times 3 is 3. So you get plus 3 there. Do the fish again. 3 times 2 is 6. Minus 1 times 4 is 4. So I get 6 minus 4. And then 1 times negative 1, that's negative 1. Minus 2 times 2, that's minus 4. So when I did n1 crossed n2, I got 8 plus 3 is 11. 6 minus 4 is 2. And negative 1 minus 4 is negative 5. Okay. So now let's calculate n1 cross n2 dot with n3. Please watch the video on dot product if you don't know what I'm doing here. I take my n1 cross n2 vector, that was this, 11, 2, negative 5, and I dot product with n3, that's 3, negative 14, and 1. So dot product gives me 11 times 33 plus 2 times negative 14, that's negative 28, plus negative 5 times 1, that's negative 5. And of course 33 minus 28 minus 5 will give you 0. Very interesting. We've got that triple scalar product is 0. So what that means, you can write therefore or implies, the normals are coplanar. What does that mean? What does that look like? Well, if your normals are coplanar, there's two possibilities. The first is what we sometimes call a star. So you get a plane like this. I'll try to draw it here. Bear with me. And then there's another plane coming down through that, intersecting it down there. And it intersects in a line, right? So there's a plane coming through, and they form a single line where they intersect. And then there's another plane coming down as well that intersects in that same line. So there'll be this line of intersection. and all their normals are parallel, making these planes either this situation, they intersect in one line, or it looks kind of like an A shape where you get one plane maybe doing this. That is a terrible looking plane. I'm going to draw this one with the same angle here. Please bear with my art skills. And then I got another plane. I'll be doing this, say. And they intersect here in a line. But then there's a third plane going across like this. And so each of them intersect each other, but never in the same spot. They got three different spots. What we're looking for is one intersection of all three planes. So it's either this star shape or this A shape. We don't know which one yet. But we're going to figure it out. How do we do that? Start working with the equations, and let's start eliminating letters. I'm going to eliminate x first, because I can see I can easily make this x into 2x and this x into 3x. So let's take equation 1 and times it by 2. That'll give me 2x plus 4y plus 3z minus, oh, forgot to multiply that by 2. That's important. Make sure you multiply everything by 2. That's a 6z minus 8 equals 0. And then equation 2 I'm going to leave alone because I want it to have that same coefficient on the x, the 2. So leave the rest alone. And then subtract. I always put my subtraction in a circle, so I remember, don't just subtract this 2x, subtract everything. 2x take away 2x leaves nothing. 4 minus a minus is a plus, so 4 plus y is 5y. 6 minus 4 leaves positive 2z. And negative 8 minus 7 is negative 15. Let's call that equation 4. I'm going to eliminate the x as well from equation 1 and 3. So let's do equation 1 times 3. I get 3x times 3 is 6y times 3 is 9z minus 12 equals 0. And leave equation 3 alone. I get 3x minus 14y plus z plus 48 equals 0. Okay, subtract everything. 3x take away 3x is 0 like I wanted. 6 minus a minus is a plus, so 6 plus 14 is 20y. 9z minus z is plus 8z. Negative 12 minus 48, that's negative 60, equals 0. Let's call that equation 5. Okay, now I got to eliminate something else. Could do the y's or the z, but the y's look easy to me. So I'm going to work with the y's. I think I'll go up here. I'm going to leave equation 5 alone, but equation 4, I'm going to times it by 4. So 5 times 4, that's 20y. 2 times 4, that's 8z. 15 times 4, that's negative 60 equals 0. Very interesting, because it's the same as equation 5. Equation 5 is 20y plus 8z minus 60 equals 0. And when I subtract, when I eliminate, I get 0y and I get 0z, and minus 60 minus a minus is a plus. Minus 60 plus 60 would be 0 equals 0. This situation right here, where you have 0 letter equals 0, no constant, means there's a line of intersection. It isn't this A case, it's the star case. So, how do I solve this? I can't possibly go on with not knowing these letters. I have to create a parameter. And I'm going to make that, usually I choose z, so I'm going to say let z equal t. And now I want to solve for the y. I can't use this equation here, it's useless, but I can sub z equals t, put a little line there so it's not confused with 2. I sub my z equals t back into one of the equations. Does it matter, 4 or 5? No, but the coefficients are smaller in 4. So I'll sub z equals t into 4. So I get 5y plus 2z minus, oh, but it's not z anymore, it's a t. Sub in that 2 times z, which is t, minus 15 equals 0, and get y by itself. So I'm going to subtract 2t both sides, and I get 5y minus 15 equals negative 2t. Now I'm going to add 15 both sides, and I get 5y equals negative 2t plus 15. And now divide everything by 5. And I have y equals negative 2t over 5 plus 3. And let's rewrite that with the numbers first, because that's usually how we write these equations. 3 minus 2t over 5, or 2/5 t. Okay, that's good. I'll call that result 6. And now I want to find out what x is. So I'm going to sub z equals t and 6. I'm going to sub what z is and what y is into one of my original equations. And I would pick equation 1 because the coefficients are smaller. And let's solve for x. Hopefully I have enough room. So we've got the first equation, x plus 2 times y, but I know what y is now. 3 minus 2t over 5. And then plus 3 times z, but z is t, minus 4 equals 0. Okay, so I get x, and then rainbow this in, multiply 2 times 3, that's 6. And then 2 times negative 2 is negative 4t over 5. Plus 3t minus 4 equals 0. Now, there's different ways you can go about solving here, but for me, when I have fractions, I like to just times them all out. It's the slower way, but to me it's the easy way. I'm going to times everything by 5. It's a bit slower, but it's going to be easier. Okay, 5 times x, you get 5x. 5 times 6 is 30. 5 times negative 4t. So here's the beauty. These 5s cancel out. That's why I did it. And you just get negative 4t. 5 times 3t is 15t. And 5 times negative 4 is negative 20. 5 times 0 is just 0. And look how quickly it's going to simplify. Here I get 5x. And then what else do I got? I've got my t's. I'm going to do them first. Negative 4t plus 15t gives me 11t. And then plus 30 minus 20 is plus 10 equals 0. Okay, I'm almost got my x. I'm going to have to sneak it in on the side here. I'll go there now. Put this arrow. I'm going to subtract, let's subtract 10 both sides first. So I get the number first. I get 5x plus 11t. And then 10 take away 10 is gone. And then on the other side, 0 take away 10 equals negative 10. Oh, went off the page there, but it says negative 10. Now I'm going to subtract 11t both sides. So I get 5x, and these 11t, take away 11t is nothing. On the right hand side I get negative 10 minus 11t. And now I'll divide both sides by 5. And I get x equals negative 10 divided by 5 is negative 2. And then minus 11t over 5, or minus 11/5 t. That's my answer, by the way. I have an equation in parametric form. X is negative 2 minus 11/5 t. Y is 3 minus 2/5 t, or 2t over 5. And z, I let equal t. That's my equation of a line. But I'll write it, you don't have to, but I'll write it as the other form. I'll write it as the form of a line, as an equation like so. The intersection is r equals, and I'll take my parametric equations to write it as a point plus a vector. So what's my point? The first 3 numbers. What are the first 3 numbers? Well, there's no number here. It's a 0. The number here for y is 3. Oh, I made a mistake. I went to the z. This isn't the z component. Yikes, I almost made a mistake right at the end. I'm looking at the x component. The x number is negative 2. Phew. The y number is 3. And the z number, the starting point, is 0. I'm changing this format of the equation. I could have left it as parametric, but I'm writing it in a different format for you. So there's my point plus a vector. So I create this parameter t times the t vector, which the z is 1t, so I put in the z spot. The y is negative 2/5 t, and the x is negative 11 over 5. So either form of the equation is good, but what we've done here in the end is solve the intersection of 3 planes when they had a line of intersection.